Part 1 Section F.4. Data Analytics. In this section will be level A questions. Memorize these terms and concepts. The CMA candidate should be able to: Business Intelligence. A. Define big data, explain the four verses: volume, velocity, variety, and veracity, and describe the opportunities and challenges of leveraging insight from this data. Big data refers to the large, diverse sets of information that grow at ever-increasing rates. It encompasses the volume of information, the velocity or speed at which it is created and collected, the variety or scope of the data points being covered, and veracity, known as the four V's of big data. Big data often comes from data mining and arrives in multiple formats. B. Explain how structured, semi-structured, and unstructured data is used by a business enterprise. Structured. It has been organized into a formatted repository that is typically a database. It concerns all data which can be stored in database SQL in a table with rows and columns. They have relational keys and can easily be mapped into pre-designed fields. Today, the data are most processed in the development and simplest way to manage information. Example: relational data. Semi-structured data is information that does not reside in a relational database but that have some organizational properties that make it easier to analyze. With some process, you can store them in the relation database. It could be very hard for some kind of semi-structured data, but semi-structured exists to e-space. Example: XML data. Unstructured data is a data which is not organized in a predefined manner or does not have a predefined data model, thus it is not a good fit for a mainstream relational database. So for unstructured data, there are alternative platforms for storing and managing. It is increasingly prevalent in IT systems and is used by organizations in a variety of business intelligence and analytics applications. Example: Word, PDF, text, media logs. C. Describe the progression of data, from data to information to knowledge to insight to action, knowledge and wisdom. Each building block is a step towards a higher level. First comes data, then is information, next is knowledge, and finally comes wisdom. Each step answers different questions about the initial data and adds value to it. D. Describe the opportunities and challenges of managing data analytics. Data as a valuable resource to unlock its potential for an organization. Managing data effectively requires having a data strategy and reliable methods to access, integrate, cleanse, govern, store and prepare data for analytics. In our digital world, data pours into organizations from many sources: operational and transactional systems, scanners, sensors, smart devices, social media, video and text. But the value of data is not based on its source, quality or format. Its value depends on what you do with it. E. Explain why data and data science capability are strategic assets. Data science encompasses several fields, including mathematics, statistics, programming and operations research. It also covers the process of data acquisition, standardization, exploration and extraction of value through actionable insights. Most importantly, data science optimizes decisions by extracting greater value from data to solve business problems and enhance processes. To achieve this increased value, organizations need analytics insights produced by data science teams with a diverse set of technical, business and communication skills. F. Define business intelligence, BI, i.e., the collection of applications, tools, and best practices that transform data into actionable information in order to make better decisions and optimize performance. Business intelligence systems, or more commonly called BI, is in fact an essential process that allows its users to accurately react to internal and external events by relying on precise analysis directly related to business processes. Simply said, BI is a decision-making tool. Thanks to business intelligence, it is now possible to access a common platform that allows us to simply and quickly view insights to optimize operations, business processes, and decision-making. BI is a comprehensive set of tools that offers several advantages, such as: gather databases in one place, quickly analyze huge volume of data in real time, integrate the latest information technologies, gain access to prepackaged application solutions, facilitate communicating information to the entire organization. Data mining. G. Define data mining. H. Describe the challenges of data mining. I. Explain why data mining is an iterative process and both an art and a science. Data mining is a process used by companies to turn raw data into useful information. By using software to look for patterns in large batches of data, businesses can learn more about their customers to develop more effective marketing strategies, increase sales and decrease costs. Data mining depends on effective data collection, warehousing, and computer processing. Data mining involves exploring and analyzing large blocks of information to glean meaningful patterns and trends. It can be used in a variety of ways, such as database marketing, credit risk management, fraud detection, spam email filtering, or even to discern the sentiment or opinion of users. The data mining process breaks down into 5 steps. First, organizations collect data and load it into their data warehouses. Next, they store and manage the data, either on in-house servers or the cloud. Business analysts, management teams and information technology professionals access the data and determine how they want to organize it. Then, application software sorts the data based on the user's results, and finally, the end user presents the data in an easy-to-share format, such as a graph or table. Data mining is the process of analyzing a large batch of information to discern trends and patterns. Data mining can be used by corporations for everything from learning about what customers are interested in or want to buy to fraud detection and spam filtering. Data mining programs break down patterns and connections in data based on what information users request or provide. J. Explain how query tools, e.g., structured query language, SQL, are used to retrieve information. Structured query language or SQL is a programming nomenclature used to do set operations, like union, intersect, and minus, to organize and retrieve information in relational databases, based on set theory and relational algebra. In any system that uses SQL, data elements or attributes, categorized into columns, are related into tuples, rows. Sets of relations with identical structure form tables. These elements, correlated rows, columns, and tables form the basis for a relational database management system, RDBMS. Describe how an analyst would mine large data sets to reveal patterns and provide insights. The process involved in data analysis involves several different steps. The first step is to determine the data requirements or how the data is grouped. Data may be separated by age, demographic, income, or gender. Data values may be numerical or be divided by category. The second step in data analytics is the process of collecting it. This can be done through a variety of sources such as computers, online sources, cameras, environmental sources, or through personnel. Once the data is collected, it must be organized so it can be analyzed. Organization may take place on a spreadsheet or other form of software that can take statistical data. The data is then cleaned up before analysis. This means it is scrubbed and checked to ensure there is no duplication or error, and that it is not incomplete. This step helps correct any errors before it goes on to a data analyst to be analyzed. Analytic Tools L. Explain the challenge of fitting an analytic model to the data M. Define the different types of data analytics, including descriptive, diagnostic, predictive, and prescriptive. Descriptive analytics looks at data statistically to tell you what happened in the past. Descriptive analytics helps a business understand how it is performing by providing context to help stakeholders interpret information. This can be in the form of data visualizations like graphs, charts, reports, and dashboards. How can descriptive analytics help in the real world? In a healthcare setting, for instance, say that an unusually high number of people are admitted to the emergency room in a short period of time. Descriptive analytics tells you that this is happening and provides real-time data with all the corresponding statistics, date of occurrence, volume, patient details, etc. Diagnostic analytics takes descriptive data a step further and provides deeper analysis to answer the question, why did this happen? Often, diagnostic analysis is referred to as root cause analysis. This includes using processes such as data discovery, data mining, and drill down and drill through. In the healthcare example mentioned earlier, diagnostic analytics would explore the data and make correlations. For instance, it may help you determine that all of the patient's symptoms, high fever, dry cough, and fatigue, point to the same infectious agent. You now have an explanation for the sudden spike in volume at the ER. Predictive analytics takes historical data and feeds it into a machine learning model that considers key trends and patterns. The model is then applied to current data to predict what will happen next. Back in our hospital example, predictive analytics may forecast a surge in patients admitted to the ER in the next several weeks. Based on patterns in the data, the illness is spreading at a rapid rate. Prescriptive analytics takes predictive data to the next level. Now that you have an idea of what will likely happen in the future, what should you do? It suggests various courses of action and outlines what the potential implications would be for each. Back to our hospital example. Now that you know the illness is spreading, the prescriptive analytics tool may suggest that you increase the number of staff on hand to adequately treat the influx of patients. In summary, both descriptive analytics and diagnostic analytics look to the past to explain what happened and why it happened. Predictive analytics and prescriptive analytics use historical data to forecast what will happen in the future and what actions you can take to affect those outcomes. Forward-thinking organizations use a variety of analytics together to make smart decisions that help your business, or in the case of our hospital example, save lives. N. Define the following analytic models: clustering, classification, and regression. Determine when each would be the appropriate tool to use. O. Identify the elements of both simple and multiple regression equations. Multiple regression generally explains the relationship between multiple independent or predictor variables and one dependent or criterion variable. A dependent variable is modeled as a function of several independent variables with corresponding coefficients, along with the constant term. Multiple regression requires two or more predictor variables, and this is why it is called multiple regression. Simple linear regression establishes the relationship between two variables using a straight line. If two or more explanatory variables have a linear relationship with the dependent variable, the regression is called a multiple linear regression. P. Calculate the result of regression equations as applied to a specific situation. Image result. For calculate the result of regression equation, the linear regression equation. The equation has the form y equals a plus bx, where y is the dependent variable, that's the variable that goes on the y-axis, x is the independent variable, i.e. it is plotted on the x-axis, b is the slope of the line and a is the y-intercept. Q. Demonstrate an understanding of the coefficient of determination, r squared, and the correlation coefficient, r. The coefficient of determination, r.2, is used to analyze how differences in one variable can be explained by a difference in a second variable. For example, when a person gets pregnant has a direct relation to when they give birth. More specifically, r squared gives you the percentage variation in y explained by x variables. The range is 0 to 1, i.e. 0% to 100% of the variation in y can be explained by the x variables. The coefficient of determination, r.2, is similar to the correlation coefficient, r. The correlation coefficient formula will tell you how strong of a linear relationship there is between two variables. R squared is the square of the correlation coefficient, r, hence the term r squared. R. Demonstrate an understanding of time series analyses, including trend, cyclical, seasonal, and irregular patterns. Time series analysis is a statistical technique that deals with time series data, or trend analysis. Time series data means that data is in a series of particular time periods or intervals. The data is considered in three types. Time series data, a set of observations on the values that a variable takes at different times. Cross-sectional data, data of one or more variables, collected at the same point in time. Pooled data, a combination of time series data and cross-sectional data. S. Identify and explain the benefits and limitations of regression analysis and time series analysis. The importance of regression analysis for a business is that it helps determine which factors matter most, which it can ignore, and how those factors interact with each other. The importance of regression analysis lies in the fact that it provides a powerful statistical method that allows a business to examine the relationship between two or more variables of interest. Time series analysis suffers from a number of weaknesses, including problems with generalization from a single study, difficulty in obtaining appropriate measures, and problems with accurately identifying the correct model to represent the data. T. Define standard error of the estimate, goodness of fit, and confidence interval. The standard error of the estimate is a measure of the accuracy of predictions. The regression line is the line that minimizes the sum of squared deviations of prediction, also called the sum of squares error, and the standard error of the estimate is the square root of the average squared deviation. U. Explain how to use predictive analytic techniques to draw insights and make recommendations. Predictive analytics statistical techniques include data modeling, machine learning, AI, deep learning algorithms and data mining. Often the unknown event of interest is in the future, but predictive analytics can be applied to any type of unknown whether it be in the past, present or future. V. Describe exploratory data analysis and how it is used to reveal patterns and discover insights in data mining. Exploratory data analysis, EDA, is an approach to analyzing datasets to summarize their main characteristics, often with visual methods. EDA is used for seeing what the data can tell us before the modeling task. W. Define sensitivity analysis and identify when it would be the appropriate tool to use. X. Demonstrate an understanding of the uses of simulation models, including the Monte Carlo technique. Y. Be able to identify the benefits and limitations of sensitivity analysis and simulation models. Z. Demonstrate an understanding of what-if, or goal-seeking, analysis. A. Identify and explain the limitations of data analytics visualization. BB. Know how to utilize table and graph design best practices to avoid distortion in the A. Sensitivity analysis determines how different values of an independent variable affect a particular dependent variable under a given set of assumptions. This model is also referred to as a what-if or simulation analysis. Sensitivity analysis can be used to help make predictions in the share prices of publicly traded companies or how interest rates affect bond prices. Sensitivity analysis allows for forecasting using historical, true data, communication of complex information. A. Sensitivity analysis determines how different values of an independent variable affect a particular dependent variable under a given set of assumptions. In other words, sensitivity analyses study how various sources of uncertainty in a mathematical model contribute to the model's overall uncertainty. This technique is used within specific boundaries that depend on one or more input variables. Sensitivity analysis is used in the business world and in the field of economics. It is commonly used by financial analysts and economists, and is also known as a what-if analysis. A sensitivity analysis determines how different values of an independent variable affect a particular dependent variable under a given set of assumptions. This model is also referred to as a what-if or simulation analysis. Sensitivity analysis can be used to help make predictions in the share prices of publicly traded companies or how interest rates affect bond prices. Sensitivity analysis allows for forecasting using historical, true data. Benefits and limitations of sensitivity analysis. Conducting sensitivity analysis provides a number of benefits for decision makers. First, it acts as an in-depth study of all the variables. Because it's more in-depth, the predictions may be far more reliable. Secondly, it allows decision makers to identify where they can make improvements in the future. Finally, it allows for the ability to make sound decisions about companies, the economy, or their investments. But there are some disadvantages to using a model such as this. The outcomes are all based on assumptions because the variables are all based on historical data. This means it isn't exactly accurate, so there may be room for error when applying the analysis to future predictions. CC. Know how to evaluate data visualization options and select the best presentation approach, e.g., histograms, box plots, scatter plots, dot plots, tables, dashboards, bar charts, pie charts, line charts, bubble charts, dd. Be able to understand the benefits and limitations of visualization techniques. EE. Determine the most effective channel to communicate results. FF. Communicate results, conclusions, and recommendations in an impactful manner using effective visualization techniques. Visual communication involves the use of visual elements, such as drawings, illustrations, and electronic images, to convey ideas and information to an audience. During presentations, business managers that properly use visual aids to communicate information will have greater success in maintaining the attention of their staff, and staff is more likely to remember the information. A potential downside of visual communication involves the use of poorly designed visual aids that are difficult to understand or see. If irrelevant information is presented, images can also be distracting and impede the understanding of concepts they should be trying to clarify. Advantage. AIDS understanding technology has led to explosive growth in the use of images to communicate and understand the world around us. The use of internet technology has turned business users into active participants that can use words and images to communicate with customers and make their brands more visible to the world. Technology that provides images, video and apps gives business owners a variety of tools to use to attract customers and expand their markets. The combination of words and images has a powerful effect on the communication of ideas. Advantage: supports oral communication. Oral communication is enhanced when visual aids are used. It's important to pair the correct visual aid with the type of oral information presented. For example, a manager discussing a data-intensive topic, such as a company's fourth quarter financial results, should consider passing out a handout that details the financial information. Presenting the information in a table format, or using a chart or graph to highlight key financial results, increases the audience's understanding and encourages participants to ask questions. Disadvantage: design issues. If a visual aid is not properly designed for its intended use and audience, it can lead to a breakdown in communication. For example, a business person presenting a new product launch must consider the size and color of the product images he wants to show to the audience. The size of his audience determines the size of the pictures he will present. A large audience requires large images that might be shown on a screen so they are visible by everyone. A small audience, such as one that can be seated around a conference room table, can be shown images from a brochure. Disadvantage: distracts from the message. A visual aid with the wrong information can cause a distraction and detract from the message the image is supposed to convey. For example, a discussion of a company's U.S. manufacturing plants might be accompanied by a map showing the location of these plants within their respective states. But if you include irrelevant information, such as tourist sites, it can distract the audience from the purpose of the map, to show the location of manufacturing plants. If you are making a presentation using slides, always try to be in charge of the remote or computer used to click to the next slide to ensure your words coincide with the graphics presented. This concludes this rather large section. Data mining, analytics and forecasting will likely be on the exam. Know all the terms involved because the questions will be level A, define, decide, explain, etc.